Swayam Prabha. Digital India. Educated India.
In my previous lecture, I have discussed about the effect of soil compressibility on bearing capacity. Now, today I will discuss the another effect, that is the effect of eccentricity on bearing capacity. That means, if the loading is not acting at the center of the foundation, it is acting away from the center of foundation because of application of moments, or the column is not at the center of the footing. So, in such cases, how the bearing capacity can be calculated will be discussed in this lecture. So, now the first the eccentricity can be in two types. One is one way eccentricity and another is the two ways eccentricity. One way eccentricity means the load is acting away from the center to a particular direction, either length direction or width direction, and in the two way eccentricity it is acting away from the center with respect to both the directions. That means, it has some eccentricity in the width direction as well as in the length direction. So, first I will discuss about the one way eccentricity and then I will discuss about the two way eccentricity. Now, for one way eccentricity, suppose in general case this is my foundation, okay, and this is x or the width direction, and this is say y direction or the length direction of the foundation. So, as I mentioned, there may be a possibility that your a moment is acting say m y, or in this way also the moment is acting which is m x. So, now because of that, the load that will act at a distance away from the center. So, suppose this is in x as I mentioned and this is in y. Now, because of we have x, m x and m y both are present. So, it will act, Q will act at this position, okay, with a distance E x, or sometimes we can write E b because it is in width direction, and this one is E y or E l because it is in length direction. Okay. But this is basically two way eccentricity, the figure that I have drawn. In y eccentricity, either it will be E x and E y will be 0, or there will be E y or E x will be 0. So, that means, in one way eccentricity, I can draw that loading is acting here with an E b value. Okay. This is my width or x direction and this is length or y direction, or there may be possibility that it can be like this also. This is x, this is y. So, loading is acting here with an eccentricity E L, okay, and this is length direction and this one is the width direction. So, that means in one way cases either mx is acting or my is acting, or there is another possibility that the column itself is not at the center of the footing, it is away from the center of the footing. So, that means this there can be either Ex or Eb, or there can be a El, or there can be both. Okay. So, now if we can draw the effective area. So, suppose if we have a one way eccentricity. So, for in case of one way eccentricity, this is the plan. If I draw the section, then I can draw in this way that this is my footing, this is ground surface. Now, here a q is acting, at the same time a moment m is also acting, okay, and this is say with b. Okay. So, in final form this can be, I can write in this way. So, this is my foundation. Now, the loading is acting here, okay, with a eccentricity q. Okay, this is the center line, because there is a moment is acting, and sometimes directly that column will act at a certain distance from the center. So, this is B. So, finally, as the loading is acting away from the center, then my effective area of the footing will decrease. So, this is say center. So, this will be now the effective area. The hatch portion will be now the effective area in this case, because here eccentricity in the width direction. So, I can write this is my L, length of the footing, or I can write this is L dash, and now initially width was B, now effective width has been reduced to B dash. So, initially it was B, now the B dash, because now the footing will not get the total area, that is A into B. Now, it will reduce to an effective area which is A dash and B dash. So, the effective area A dash is which is B dash into L dash. Okay. And initial area, original area was B into L. Now, when we calculate the bearing capacity and the other factors, then we have to now consider this effective area, and I have discussed in my previous lectures that as per different theories, the different factors we have to calculate by considering either A or B or A dash and B dash. Those things are mentioned. So, we can say that now that my B dash value will be, what is the B dash value? B dash value is equal to B minus 2 E x or E b. I should write E b, because this is my E b. E b. E b is the how much distance the load is acting away from the center towards the width direction. Similarly, E L is the how much distance the load is acting away from the center towards the length direction. Okay. So, now here basically the my load is acting here. Okay. So, that is why this effective area is reduced in this left hand side. So, now this is the one case. Now, if the loading is acting away from the center towards the length directions, because we are talking about the one way eccentricity. So, in such case my L dash will be equal to L minus 2 E L. Okay. E L again the same distance that I have discussed. So, now how in terms of moment we can calculate the values, that suppose we have a moment m x and m y. Okay. So, my E x or E b will be equal to m y divided by q. That means, if there is a moment which is acting with respect to x y axis and there is a load acting q, then we can determine the E b and or E x in this way. And sometimes the E b or E x can be directly given if the load is itself acting away from the center. So, similarly, I can write that E y or E L is equal to m x divided by q. Okay. So, there is a q is also acting here. So, there is a q is also acting here and two moments are acting. There can be two moments or one moment, because in one way eccentricity one moment is acting, in two way eccentricities both the moments can act. Okay. So, now this is my I can calculate in this way E x and E b, and then the effective length and width I can calculate by using these expression. Now, this is in case of one way eccentricity where I can calculate b dash and L dash. Okay. So, now if I go to the two way eccentricity, so in such case in two way eccentricity how I can calculate the eccentricity value, that I will discuss here. Now, in the two way eccentricity there are four cases are discussed, which is proposed by these two authors in 1985. So, first case that now if you go back to that previous expression, those are given. So, now here you can see that if my E b is equal to half of b, that means if E b is equal to b by 2 or E b by b is equal to 1 by 2 or 0.5, then what? Then the b dash value will be equal to 0. So, that means that in such case this b dash value is equal to 0, that means the load will act at the edge of the footing. Similarly, if the E L is equal to L by 2, that means then the load will act at the edge of the footing. So, theoretically I can write the maximum limit of E b or E L is half of the width or the length. Okay, that is the theoretically I can write that. So, now here I have given four expression. So, those four cases, the first case is that if E L by L is greater than equal to 1 by 6 and E b by b is also greater than equal to 1 by 6. Okay. Why 1 by 6 is given? Because that if the footing eccentricity is greater than 1 by 6, in case of say one way eccentricity, we can say that if my footing eccentricity is greater than 1 by 6, then in case of the pressure distribution. So, this is my pressure distribution, because as the loading is now eccentric. So, this will be the pressure distribution. Okay. Okay. So, this is the pressure distribution. So, now is if in such case I can write that this is my Q max and this is Q min. Okay. So, that Q max, this can be written that Q by B L 1 plus 6 E L or E B divided by B. In case of L, this will be L. Okay. And the Q mean will be Q divided by B L 1 minus 6 Q B divided by B. If the eccentricity in the length direction, then it will be E L. So, you can see that if that sorry, this will be E B. If E B by B is E B by B is equal to 1 by 6 equal to 1 by 6, then the E mean value will be 0. So, that means, if E B by B is less than 1 by 6, then there will be a negative pressure will be developed below the footing. So, that is why this 1 by 6 is a value that we have to keep in mind. So, that is why this, if for one way eccentricity, if we put that E B by B less than 1 by 6, then there will be a negative pressure will be developed. So, that is why you have to keep this 1 by 6 in mind during our selection of the eccentricity. So, that is why the other 4 cases are taken according to that. That means, we have now talking about two values. One is 0.5 theoretically, that can be the maximum value of any eccentricity E B or E L, because in such case the load will act at the edge of the foundation, and another is E B by B is 1 by 6. That means, the E B or E L is 1 by 6 times of B or L, in such so that there will be no negative pressure below the foundation. So, now I can write that other cases, that is why the first case is taken as E L by L greater than equal to 1 by 6 and E B by B equal to greater than equal to 1 by 6, because that is why this limit is considered, because as I mentioned, this is the important thing, that these two values 0.5 and 1 by 6. So, now in case 1, if this is the loading condition, now this is the footing, this is the center line, and this will be the width of the footing, and this is the length of the footing. Then the effective area will be like this. okay, because now my load will act here, here the Q will act, and this one is E L and this one is E B, and both are greater than or equal to 1 by 6. So, now the effective area will be this one. Okay. So, now effective area will be this one, and then I can write that this is equal to L 1 and this one is equal to B 1. So, how we can calculate these L 1 and B 1, because that is important. So, now my effective area will be, so this effective area A dash, this is the triangle, this shaded portion is the triangle. So, this will be half L 1 into B 1. Okay. So, now where B 1 I can calculate by using this expression B 1.5 minus 3 E B by B. Okay, remember that. And L 1 I can calculate by L 1.5 minus 3 E L by L. Okay. So, now the effective length L dash will be equal to the longer of value B dash B 1 or L 1. That means, the L dash effective length will be now the larger value of or the B 1 or L 1. That means, which one is the higher value, that we have to consider as a L dash. If L 1 is greater than B 1, then L dash is L 1. If B 1 is greater than L 1, then L dash will be the B 1. So, that means, if B 1 is greater than L 1, then L dash will be equal to B 1, or if L dash greater than B 1, then L dash will be equal to L 1. Okay. So, now the effective width B dash I can calculate, because now I know what is, I can calculate L 1 B 1 from these equations, two equations. So, I know what is effective area A dash. So, A dash I will get, once I will get the A dash and L dash will be the longer value of B 1 or L 1, then my B dash will be equal to A dash by L dash. So, this way I will get the effective area as well as the effective width and length in case of two-way eccentricity, case 1 of this condition. Now, I will go to the case 2, when the case 2 where the condition is that E L by L is less than 0.5, because I mentioned these two are the very important value 1 by 6 and 0.5, and E B by B is in between 0 to 1 by 6. Okay. So, E B by B in between 0 to 1 by 6. So, in such case, case 2, my effective area will be, so this will be the foundation, this one is B and this one is L, this is center line, and your loading is acting here, this is E L and this one E B. This is the position of Q. Now, the effective area in this case will be like this. Okay? So, this will be the effective area in this case. Okay? So, we have this is L 1 and this one L 2. Okay. Now, B is this side is fully covered within the effective area. So, in such case the effective area I can calculate, because this is a trapezoidal. So, I can calculate by, because this is equal to B. So, this will be half L 1 plus L 2 into B. Okay. Now, how I will calculate the B I know, because I know the length and width of the footing. How I will calculate L 1 and L 2? So, L 1 and L 2 I will get from this figure. So, this figure you can see, let me explain this figure. So, first you will calculate what is E L by L. So, you have to know the eccentricity, then divided it with the length, that means eccentricity along the length direction, divided it with the length of the footing, then you will get a value, and that should be less than 0.5. So, that is why it is 0 to 0.5. So, this value is given, and then we have to calculate E B by B, because E B by B is in between 0 to 1 by 6. So, 1 by 6 is roughly 0.17 or something. So, that means 0.167 actually. So, that is why this is given from say 0.01 to 0.167, because 1 by 6 is 0.167. So, now this x axis is given the L 1 L or L 2 L. So, I will get in terms of ratio L 1 by L and L 2 by L. Okay. So, now in this figure, if you look at this figure, here there is this straight line which is this line, okay, where this side also you can see E B by B is 0.01, 0.02, 0.04, 0.06 to 0.167, and this side also it is going 0.01, 0.02, 0.08 to 0.16, which is 0.167. Okay, so that means both side it is E B by B, this side also E B by B, this side also E B by B. But if I go towards the right side direction, that means if I go this direction, then I will get L 1 by L, and if I go towards the left direction, then I will get L 2 by L. Okay. So, for example, I have a E B by E L by L is 0.2 and E B by B is 0.1. So, I want to calculate L 1 and L 2. So, this is 0.2 say E L by L and E B by B is 0.1. So, 0.1 is this graph. So, 0.2. So, this is the value, one value. Okay. This is one value, and that is corresponding to this graph. I will get this value is, so this is 0.9. So, this will be around 0.88. So, but this 0.88, as I am going towards the right side direction. So, this will give me L 1 by L. Okay. Now, if I go to this direction, that means the below this straight line, if I go the above, or another way I can say, if I go to the above the straight line or the line that I have shown, that the middle line, above that, then I will get L 1 by L. If I go below, I will get L 2 by L. So, L 2 by L will be how much? This is 0.1, this is 0.1, this is 0.2. So, this is the value. So, this value is 0.22. So, that will be give me the L 2 by L. Okay. So, L 2 by L. So, this way I will get the L 1 by L, L 2 by L. Now, this is valid, these two values are valid if I have considered E b by B is equal to 0.1 or E L by L is equal to 0.2. Okay. So, then this way I can calculate L 1 and L. Now, if once I get the L 1 by L or L 2 by L, then you have to multiply it with the L and I will get the L 1 and L 2. So, once I get the L 1 and L 2, I will get the A dash value and the B dash value is, or I should say that first the L dash is equal to longer of L 1 or L 2. That means, the longer value between L 1 and L 2 will be considered as L dash and the B dash will be equal to now A dash by L dash. Okay. So, this way I can calculate the effective area, effective length and effective width of the foundation. So, these are the two cases that I have discussed, that case 1 and case 2. There are two more cases. So, in the next class I will discuss two more cases for this two-way eccentricity and then I will solve one particular or few problems related to eccentric loading to determine the bearing capacity of the foundation. Thank you.